Hey y'all, welcome to my YouTube channel. Today we're going to talk about types of functions, we're going to talk through transformations and key features. So here we go. So number one, this is our rational function right here, rational R-A-T-I-O-N-A-L. And that's given by f of x equals 1 over x. So these are all the parent functions. They're the most basic ones. Next we have square root, which is f of x equals the square root of x. And then we'll have the cube root, which looks the same, but it's got that cute little 3 on the edge here. Then we'll have the exponential function and the logarithmic. Log's what we've been focusing on. So remember, these are inverses of each other, so they're going to have a base, and the base will be the same. So this will be f of x equals a log base b of x, and that's what we've got going on. So first, we just want to see how are these 5 graphs, so these 5 graphs that we got going on here. So the question is, how do these 5 graphs, how are they going to transform, okay? And they all follow the same general rule, right? So we can see the rational function right here. H and B are going to be on the bottom, A is on the top, K is on the outside. A is outside the square root, B and H will be inside the square root, K is on outside. And here we have A on the outside of the log, H on the inside, and K. There is no B for log, which is really nice. If you need a reminder, if A is bigger than 1, that's a stretch. A fraction in between 0 and 1, compression. Less than 0, a few people have struggled with this. This just means negative. If A is negative, there's a reflection of the x-axis. Here's all the information for B. And remember, on the inside, if it's plus h, that's going to go to the left. If it's minus h, it's going to go to the right. K is going to go up if it's positive, down if it's negative. So let's just look at a few questions. You can use Desmos for all of these. I do want to kind of just help you guys get a little bit faster and more efficient. So let's just see this. If f of x, if f of x equals log of x is changed to g of x equals 2 f of x minus 3 plus 1, how is the graph transformed? So the first thing I look for is the k value. And that's on the outside. So I see this plus 1 means it's going to go up. So I'm looking for 1 unit up. So this is good, makes me happy. This is good for B, it makes me happy. 1 unit down makes me sad. I know C is out. And D also says 1 unit down, so I know that's out. Now I'm going to look at the minus 3 here. So that's H. So if I have minus H, remember, minus H right here means I'm going to go to the right. So I'm looking for the word right 3. So I see 3 units right for A, happy. 3 units left for B, which is sad. And so we're going to be out, so the answer is A. Great, I'm going to go to the second problem. So once again, you can kind of just look at this and piece it together. I could show you on Desmos. I'm going to trust that you guys know how to copy this on Desmos, copy this and graph and match. One of the other things you can do is this plus 3 right here. This is going to go up 3. So I'm looking for the graph to literally have shifted up 3 units. For these graphs, that's going to tell you your horizontal asymptote. And so we can kind of see real quick here that, hey, this is a problem. It's touching the asymptote for this first answer choice, so that's out. Then this x minus 4, that x minus 4 is going to go to the right 4. So that will give us our vertical asymptote for these functions, which gets us right here. That's going to be our answer. Once again, you totally can graph this on Desmos, graph that on Desmos, and see which one's the same. So Desmos is a good backup, but you can just do the shifts and figure it out from there. Okay, for the next one, same thing. We could go to Desmos. I'm going to trust that we know how to do that. This says if f of x equals the square root of x plus 2. So one thing I want to point out is notice they give me a k right here. They're already telling me the graph goes up 2. I already know my graph's doing this. They're telling me that this function is transformed to create the function g of x shown in the graph. In terms of f of x, which equation represents g of x? Well now, if I look at my graph, I can see that g of x needs to go to the right 3. So when I go back up to my equations, well, right 3 is going to be h, so we're looking for inside the parentheses, and it's got to be negative. So I'm looking for minus 3, which is going to give us a. This is going to be right 3. Answer choice B would have been to the left 3. Minus 3 on the outside is down. This would have been plus 3. So both of these are k values. And these are h values. So A is going to be our answer. Once again, Desmos is your friend here. You're just trying to graph and match. Okay, and that's what we got on transformations. So go ahead and flip your paper over. We're now looking at asymptotes. So just as a quick reminder, asymptotes, those are a line that the graph approaches but never touches. We have two main types. There's a vertical asymptote and a horizontal asymptote. So your horizontal is going to be your y equals. Vertical is going to be x equals. And you get kind of just this business going on right over here. So we have x equals negative 4 for my vertical, y equals 3. It's kind of just shaping the graph. That's the idea. So when I look at question number 1, it says which graph has a vertical asymptote of x equals 5 and a horizontal asymptote of y equals 2? Easiest way to do this one is just draw your graph, your asymptotes. So x equals 5. This looks good for me for A. X equals 5 is right here. For B, this is a problem. C, x equals 5. This also looks really good to me. Now I'm going to go my horizontal, so I'm going to find where y is 2 and draw a line. So y equals 2 for A. That I do not like because it's touching this moment right here, so that's upsetting. So A should be out. B we already eliminated because of x equals 5. So C, if we look right here, hey, y equals 2, happy, happy, happy. The answer is going to be C. All right. So now, there's a couple other ways. You can do it from an equation. If you are advanced, you do need to watch this part. If you are comprehensive, you can watch maybe if you want to, but it's not necessary. So here, from an equation, to find your vertical asymptote, you set the denominator equal to 0. So that's just a fancy way to say the bottom. So vertical asymptote is going to be like this. Vertical x plus 4 equals 0. X equals negative 4. Horizontal is going to be just your k value, so y equal to negative 3. Go ahead and try this one out over here. So 2x plus 3 equals 0. I'm going to subtract 3 from both sides. 2x equals negative 3. Divide by 2. Most people want to subtract 2. That's incorrect. And for my horizontal, you're going to get y equals negative 4. All right, we are almost done. Thank you for your patience. Let's keep going. All right, finding x-intercept. So once again, you can definitely do Desmos, and I would suggest that you do. But you can set your numerator equal to 0. So if I look at this one, x equals 0, x plus 4 equals 0, and x minus 4 equals 0. So that's done. I know I'm going to have an x-intercept at 0. For this one, I know x equals negative 4. And I know for this one, x equals positive 4. So all examples of setting the numerator equal to 0. Of course, you can also go to Desmos and see where they hit the x-axis, which is what I would go ahead and challenge you guys to do for the next 3 examples. So 1, 2, and 3, go ahead and take some moments, solve those on your own, and then we're going to go from there. All right, comprehensive, if you have watched this far, you can go ahead and stop. Advanced, we're going to keep going just a little bit further. Okay, so for complex rational functions, vertical asymptotes, if you have x squared minus 4, you got to set that equal to 0. You can use Desmos to help you with this, but we're going to go ahead and factor x squared minus 4 real quick. And we should get x equals negative 2 and x equals 2.